Hello everyone. In this video, I'll introduce improper integrals, and in particular, we will study improper integrals over infinite intervals. Okay, to start with, let me recall two important facts when we work with definite integrals. When you have definite integral, remember always the limits, the bounds, are numbers. Any constant, any real number we put there. And another thing is that the function is assumed to be continuous on the given interval, is continuous on the closed interval AB. If any of these doesn't hold, we are dealing with improper integrals. That is basically where this improper integrals come in. So an improper integral is a definite integral such that either one of the limits is infinity, at least one of the limits. At least one of the limits is plus or minus infinity. So we are talking about a to plus infinity of f of x dx, or integral of negative infinity to b f of x dx, or from negative infinity to plus infinity f of x dx. Or f of x, the integrand is not continuous on the AB, the closed interval AB. Okay, so these two different types are the things that we will cover in this section, but for this video and this unit, we will study only those parts which we call them improper integral over infinite interval. Okay. Before I start the definition, exact definition, I should put one key note here, that when you talk about an improper integral, so improper integral, you're not dealing with just with a definite integral. It is, so this is the way I like to put it, is a definite integral but you have to bring in a limit as well. So you have a definite integral and a limit as t goes to plus infinity, or t goes to minus infinity, or t goes to one number, which is this continuity in AB. Improper integral is not just an integral. You always should think of a package, which is a definite integral and a limit as t goes to something. Okay, just with these generalities in mind, now I can start defining what does those integrals mean. So for integrals of the form from a to plus infinity, I'll say that I'm assuming that f, the function, is continuous on an interval a to plus infinity. Then when I write down a to plus infinity of f of x dx, what I really mean is this. You replace infinity by a variable t, go from a to t f of x dx, or use fundamental theorem of calculus, evaluate this and you will get a function in t. Then find the limit of that as t goes to infinity. If you don't do that, doesn't make sense. So you cannot apply fundamental theorem of calculus with one of the limits to be plus infinity. That's why first we take down that plus infinity, write it as limit, but then put boundary as one of the boundaries as t, so that you can apply fundamental theorem of calculus. Okay, if that limit exists, the value of that improper integral is equal to that limit. The second case is that when the function, the lower limit is negative infinity. So in that case, we are assuming that f is continuous on negative infinity to a. Then by negative infinity to a of f of x dx, we mean, well, you go from, okay, let me write b there, from replace negative infinity by t as variable, yes, and go from t to b. So here I should do that one as well. Then you integrate this. Yes, evaluate it. It will give you b is a constant, but t will give you a number, a variable, and the function after you integrate, you will get a function in t. Then let t goes to negative infinity. So in both cases, if the limit exists, then the value of the limit is equal to value of the function, the integral. If the limit does not exist, we say the improper integral is divergent. If the limit exists, the value is there, and we call it convergent. So if the limit exists here, then we call it convergent, and the value is the value of the limit. Okay. How about if both of these guys are, one is plus infinity, the other one is negative infinity? So if f is continuous, this time on the whole negative infinity to plus infinity, then we define negative infinity to plus infinity f of x dx to be sum of these two improper integrals. If both of them exist, so provided that both negative infinity to a f of x dx and a to plus infinity of f of x dx exist or converge, is convergent. Then the values you take and put them, add them, and you give the value of the integral from negative infinity to plus infinity. What if one of these two integrals is divergent? Then the integral, the negative infinity to plus infinity, will be divergent integral. Okay? So you have to be able to find each one, find both of them must be convergent, and then add the values, and that will give you the value of the negative infinity to plus infinity. Let's do some examples. So integral of this guy. So, well, first we replace the plus infinity by t, and then integrate. Well, integral of e to the power negative x is negative e to the power x. We go from 2 to t, and that will give you negative e to the power minus t minus negative e to the power minus 2. So that is negative e to the power negative t plus e to the power negative 2. Now, limit of the integral 2 to t e to the power negative x dx as t goes to plus infinity. We first evaluate the integral, then find the limit of that. So this is this. And well, the second part is just constant, but what is limit of e to the power negative t? Well, the graph of e to the power negative t will be helpful here for us. So e to the power negative t has this graph like that. If t goes to plus infinity, the function goes to 0. So this limit is equal to 0. So minus 0 plus e to the power negative. So this means that, well, our integral is convergent. Our improper integral is convergent. And it has a value. The value is 1 over e squared. So that I can now write it like that. Okay, so let's do another integral here. So first I have to replace that negative infinity by t dx. How about I do find this integral first? How do I find that? So if I choose u to be 1 minus x, then du is going to be negative dx, and this will give us 1 over root u and negative du. And then this is basically u to the power negative half du, and that will give us negative 2 u to the power half, which is just root u plus c. And plug it in back. Oops, everything became black. Everything plug it back here. So I have negative 2 root 1 minus x plus c. Now, why did I do that? Because now I want to replace negative infinity by t and actually evaluate this guy. So that is going to be negative 2 root 1 minus x, go from 0 to t. By the way, here it's important to see that 1 over root 1 minus x is defined, or is continuous on whole interval negative infinity to open 1. And here then we have negative 2 root 1 minus 0 minus negative 2 1 minus t. And this is negative 2 plus 2 1 minus t. Okay, now that I found the integral t to 0 of the integral, then I found the limit of that as t goes to negative infinity. So this will go limit of, you see, I evaluated, this is just function of t, and I'm just trying to find the limit of this guy here. See, as t goes to negative infinity, negative t will go to plus infinity, 1 minus t will go to plus infinity, then root of 1 minus t will go to plus infinity, and then you subtract 2, is still going to be plus infinity. Plus infinity is divergent. So this is divergent then. And divergent integrals doesn't have value, so I don't need to put any value there. Okay, now we did work with e to the power negative x. Now this goes from negative infinity to plus infinity. When it comes to both of the limits to be negative infinity plus infinity, then you have to consider two different integrals. Let's say we pick any number from 0 and then go this guy. So we have to study each one and make sure that both of them are convergent and find the values and then add those ones. It will give us what we are looking up there for. What about this number a that in the definition comes? In the definition, we just put a, but that's up to you. You can put any number you like. In this example, I choose to put 0, but then I remember that up here we had a 2. Why don't I then change it to 2 so that I can use the result from part 1. The key point is that if you start with 2, both of them will become 2. So what we showed here was that this one is convergent, and the limit was 1 over e squared. How about this other one? Well, I have to first go to from t to t to the power negative x dx. This is negative e to the power negative 2 up there minus plus e to the power negative t. Now, if I find the limit of this as t goes to negative infinity, what I will find is limit of, this is just a constant, plus e to the power, okay, let me pass that constant out there, and then limit of e to the power negative t as t goes to negative infinity. Well, again, remember the graph of e to the power negative t as t goes to negative infinity, this guy goes to plus infinity. So that means that this has plus infinity limit, which means this guy here, so that means that we were working on this, is divergent. So one of the integrals were convergent, the other one was divergent. Then the whole integral is going to be divergent integral. Okay. Let's do one more example here. Okay, so we have this one. So let me first find the antiderivative of this guy. Maybe I should. Well, okay, this is from negative infinity to plus infinity, so we have to fix a number and go from negative infinity to that number, and from that number to plus infinity. Any number you fix, that must be same for both of them, and we go to the same direction. Okay. Now, for both of them, I have to find antiderivative of x cubed e to the power negative x to the power 4. So I will go ahead and do it here. So e to the power something, I would say just put u to be that something, or here I would just put x cubed, because the derivative of x to the power 4. Derivative of x to the power 4 is 4x to the power 3 dx, which is kind of there, yes. So if I multiply 4 and then divide it by 4. So this way I have 1 over 4 integral of e to the power minus u du, which will give me negative e to the power negative u over 4 plus c, and that is negative e to the power minus x to the power 4 over 4 plus c. Now, let's go back. There are two integrals that we have to study separately. One is this guy. The other one is this one here. Okay, what should I do for each one? For each one, you take out first the negative infinity or the plus infinity and plug in t for that. Then evaluate it. And then when you plug in everything there, this will be negative 1 over 4 plus e to the power 0 is 1, yes? So this is e to the power negative t to the power 4 over 4. Then find the limit of this integral as t goes to negative infinity. This will be the same thing as finding limit of this guy here as t goes to negative infinity. Well, here you have to note that when t goes to negative infinity, t4 goes to plus infinity. And then negative t to the power 4 goes to negative infinity. As a result, e to the power negative t to the power 4 will go to 0. You check the graph again. We just did have it up there. So this will be negative 1 over 4. So the result is that, yes, this is convergent. And the value is this guy here, negative 1 over 4. How about the other one? So we have to do same things here. So I'll do a little bit faster here. So replace plus infinity by t. The same thing will come out with one difference, that this will be first. Then will be 1 over 4. Yes, and then find the limit of this guy. T as t goes to plus infinity, which is the same thing as saying find the limit of this guy. But we know that this piece here, as you see, with the same argument, this will go to 0, and this other one is going to be 1 over 4. Very nice. So what we showed is that, yes, this other one is also convergent. And then the value is 1 over 4. So now that both of them are convergent, we can use the definition. So we can go from negative infinity to 0. And this will give us, then added to from 0 to plus infinity. Both of them were convergent. So as a result, this integral, we already know that this is convergent. But we are looking for the value. The value here is going to be negative 1 over 4 for the first one plus 1 over 4 for the second one. They will add up to 0. Yes, so that is convergent. The value is 0 as well. Okay, so these were the definitions of improper integrals, and then we were able to evaluate some of these guys, some examples for this guy.